All right, how's everyone doing? I'm going to go over these warm-up problems. If you had any questions, go ahead and watch this part. If not, you can go ahead and skip forward. Here we go. Number one, you should start to recognize these patterns of how we solve this quadratic. This one, we just have an x squared term and a constant. So this one I'm going to solve by taking a square root on both sides. So I'm going to isolate that x squared. So let's add 32 to both sides. We get 4x squared equals to 32. Continue to get that x squared by itself, divide by 4. I get x squared equals 8. And we undo that square by taking a square root of both sides. So I get x equals, now remember, anytime you get a square root of both sides, you get a positive and a negative. Don't forget that plus or minus square root of 8. All right. Simplify that radical though, okay? We want to take a look at this 8 and see if there's any perfect squares, any groups of 2 that I can pull out. So 4 times 2 is 8, and then 4 is 2 times 2. Hey, I've got a group of 2's, so I can pull one of those out, right, because I've taken the square root of it, and then one of them doesn't have a pair to come outside. So here's my answer. A couple things, don't forget that plus or minus, and always simplify that radical. Number 2, I notice I have an x squared, an x, and a constant. This one I want to set equal to 0, and then factor into 2 binomials, okay? I'm going to add this 30 to the left-hand side. So I get negative x squared plus 13x plus 30 equals to 0. Now here's the thing, I don't like that negative sign at all. So to get rid of that negative sign, I'm going to multiply everything in here by -1, and that's just going to change all my signs around. X squared minus 13x minus 30 equals 0. Now I can factor, okay? We're factoring a trinomial into 2 binomials. I'm looking for 2 numbers that add to -13, multiply to -30. So I'm just going to list out what multiplies to 30. 31, 15, 2, 10, 3, 6, 5. Now I'm going to look for which ones add to -13. Careful here because they have to multiply to -30, so I know one of these numbers is going to be negative and one's going to be positive. So if you see the 10 and 3, again, one of them has to be negative. So if I have 10 and -3, that's not going to get there. So careful with that. But the 15 and 2, to one of them to be negative, add to -13, I'm going to have -15 and +2. So I have x minus 15, x plus 2. At this point, once we've factored, we're going to set each factor equal to 0. Okay, don't forget that step here. We got to continue to solve. This is an equation. So we have x minus 15 equals to 0 and x plus 2 equals to 0. Go through these steps. Go ahead and solve these. Add 15 to both sides. We get x equals 15. Subtract 2 from both sides. We get x equals -2. Okay, again, when you see that equal sign, we are solving these. Your answer should always be in the form of x equals, okay? Finding the values of x that make that equation true. Number 3, I notice I just have an x squared term and a constant, so we can solve this one by square rooting like we did number 1. I'm going to subtract 13, so we get -4x squared equals to -13 divided by -4. X squared equals a negative divided by a negative is just positive 13 over 4. Let's undo that square by taking a square root of both sides. So I get x equals, don't forget that plus or minus, square root of 13 over 4. All right, don't leave it like this. A couple things going on. Fraction inside of radical, right? So we can't have a radical in the denominator. So first thing I'm going to do, I'm going to split this up into the square root of 13 over the square root of 4. Now, before we start to multiply by the square root of 4 over the square root of 4, let's see if we can simplify either of these radicals. And you might notice that the square root of 4 is a perfect square, right? So we get plus or minus the square root of 13, but hey, the square root of 4 is just 2. Don't make life harder than it needs to be. Just take that square root. Now we have no radicals in the denominator. So this is a rational number. And we are happy. We made the math gods happy. All right. Number 4. Again, just an x squared and a constant. We're getting pretty good at these, right? Subtract 16. 4x squared equals negative 16. Again, dividing by 4. I see a pattern. X squared equals negative 4. Take the square root of both sides. We get x equals plus or minus the square root of negative 4. Square root of negative 4. Uh-oh. Can we take a square root of a negative? I'm going to ask my calculator here. Square root negative 4. Error, non-real answer. Non-real answer. Non-real answer. What does that mean? Well, that's what we're going to look at today. All right, we're going to take a look at how can we take a square root of a negative number. All right. All right, number 5 real quick. This was our lesson for Wednesday. I always like to sketch a graph. Basically, we have the height of something and the time of something. It's starting at a certain height, and over time, it is falling to the ground. So we have a rooftop 50 feet above the ground, and someone is up there dropping water balloons, which is pretty mean. Although right now it's hot out, I wouldn't mind getting hit by a water balloon. Let's take a look. We're going to use this function here. Okay, I'll give you that on the quiz or test, but you need to know where to plug stuff into, okay? So the height after t seconds is equal to the initial height minus 16t squared. You can also see it written like this, where it's negative 16t squared plus the initial height, which is how I showed you last class. All we have to do is plug in the initial height here, which is 50 feet. And now it's saying how long does it take to hit the ground, okay? So I'm finding the time when the height equals 0, right? Hitting the ground is when your height is 0. So I'm just plugging in h equals 0 to this left side of my equation. And again, we have just a t squared and a constant, so we're going to solve by square rooting. Let's go ahead and subtract 50 from both sides. Negative 50 equals negative 16t squared. Divide by negative 16. At least we're not dividing by 4 again. We get t squared. I'm just flipping this around. I like my variables on the left. I don't know. 50 over 16. Square root of both sides. T equals, remember, we're dealing with time now. We don't need that plus or minus. I know you want to keep it because I yelled at you and said you always need plus or minus, but we're dealing with just positive time. The square root of 50 over 16. Here's another thing. Normally I say exact form, but this one is a word problem. I want to know how many seconds rounded to the nearest tenth. So let's go ahead and just plug this into our nifty calculator here. I get time equals 1.7677 seconds. Now let's take a look rounded to the nearest tenth up here. Tenth is 1 decimal place. So I want to look at the second decimal place here, the 6, and see if it bumps up that other one. Since 6 is above 5, it's going to bump up this to 1.8 seconds. So let's be precise with our rounding and our answers and our units and all that good stuff. So, all right, that's the warm-up. Hope you did well on that. Let's go ahead and look at today's lesson. All right, so we've been dealing with real numbers up until this point, where if you have x squared equals 1, if you take a square root of both sides, you get x equals plus or minus 1. You get 2 solutions, right? Okay, because you can plug in, if you plug into this original equation, you would have negative 1 squared equals 1, and also positive 1 squared equals 1. They both fit this original equation. Okay. Now, the second part, how many numbers, if you square them, equals 0? Well, if you take a square root of both sides, you just get x equals 0. There's no plus or minus. There's just 0. All right, today is what we're gonna look at this, because if you take a square root of both sides here, you get x equals plus or minus the square root of negative 1. And up until today, you've learned in math that you can't take a square root of a negative number. And mathematicians ran into the same exact problem, but they ran into this, that they said, hey, we have to do something about this because we're getting this a lot. So this is where they created something called imaginary numbers. All right, imaginary numbers to account for situations like this. Now, it doesn't mean they don't exist. It doesn't mean they're not real. It doesn't mean you can't see them. I'm going to show you what they mean on this next slide, okay? All right, so imaginary numbers, this is important. Copy this down right here, okay? We have the square root of -1. Whenever you see the square root of -1, up until today, you said does not exist, okay? But starting today, we know now that the square root of -1 equals I. I stands for imaginary number, okay? So go ahead and write that down. That's key to today's lesson and solving these problems. All right, so let's take a look at something like the square root of -18. Remember, we need to simplify something like this. So I'm going to break this down. I'm going to write this as the square root of 18 times -1. And then with this, I can give each of these their own radical. So I can write the square root of 18 times the square root of -1. And at this point, remember, we said over here on the left that the square root of -1 equals I. So we have now the square root of 18, and the square root of -1 here is just I. Okay, so now I just need to break down that 18. 18 is 9 and 2, 9 is 3 and 3. Hey, there's my pair. One of them gets to come outside. Let me do it right here. So I get a 3, and I get a 2 inside the radical, and then an I. All right, a couple things here. If you leave the I at the end here, make sure that that radical doesn't cover it, because we don't want to make sure, we want to know that this is outside the radical. So you can either write it like this, or you can write 3I root 2. Either one of those answers. We just don't want it to look like this, like I almost had it, where we don't know if that I is inside or outside of the radical, okay? All right. Next one here, square root of -4. Again, now we know this is an imaginary solution, so we're going to get an I. All right, you don't have to go through all these steps like I just did on the last one. You can if you want, or from now on, if you see a negative square root of -4, just know that this negative is going to come outside as an imaginary number, okay? So basically we have now the square root of -4 is really just the square root of 4I. Okay, that negative becomes an I, and we know the square root of 4 is just 2, so we get 2I. Okay, you can go through these steps like I did on the previous problem, but we'll start to see when you get a square root of a -1, just bring that I outside right away. Okay. All right, this next one's got a lot going on. This is a mess, right? We got a negative that's going to become an I. We have a fraction inside of a radical. Oh my goodness, where do we start? Well, I'm going to start by breaking this up. I'm going to give the top its own radical and the bottom its own radical. And this negative sign here is going to become an I. Okay, I can write this on the top. I can write it next to it. I just can't write it on the bottom. So I can write it here. I can write it in front of the square root of 3. I just cannot write it on the bottom, okay? So I'm going to leave it there because that's going to help. Now, again, what you're thinking, radical in the denominator, I'm going to multiply by root 4 over root 4, but it's easier than that. Let's go ahead and simplify either of these radicals if we can. And I know what you're thinking. You're like, I know the square root of 4. That's an easy one. The square root of 4 is 2, okay? So this is okay for us. We don't have any radicals in the denominator. We have no negatives inside of the radical. And again, we can either write it in this form here. We can write it as root 3I over 2. We can write it as root 3 over 2 times I, or even not the time there. We just got to make sure that I doesn't end up on the bottom somewhere, okay? So all of those are different forms of the same answer. All right. So again, this is the key here. I is the square root of -1. So now, starting today, we can take the square roots of negative numbers. All right, couple practice problems here. Let's go ahead and take a look. All of these are in the form of just an x squared and some numbers. So these are all going to be solved by taking square roots. All right, first one here, subtract 3. negative 5x squared equals 7. Divide by negative 5. We get x squared equals 7 over negative 5 is the same thing as negative 7/5. Okay, you can put the negative sign either way. At this point, you should start to see, hey, x squared equals a negative number. I'm going to get imaginary solutions. I get to use my I, right, that I just learned. Take the square root of both sides. We get x equals plus or minus the square root of negative 7/5. So I'm going to do a couple things here. I'm going to give the 7 its own radical, the 5 its own radical, and that negative sign, it just comes right outside as an I. Okay. At this point, hey, Mr. Miller, I can't have a negative 5 in the denominator. That's irrational. Let's rationalize that. So we're going to multiply by the square root of 5 over the square root of 5. If I do that, let's go down here. I get x equals plus or minus this. I'm just multiplying right across the top here. The square root of 7 times the square root of 5. On the bottom, we should know square root of 5 times square root of 5 is the square root of 5 squared, which is just 5. Don't forget that I. And again, on top, we can just combine these into the same radical of 7 times 5 is 35 over 5i. All right. At this point, you want to see if you can reduce, but the only thing is this 35 is inside of a radical, and the 5 is outside of a radical, so we can't do anything with that. If you want to check if we can simplify 35 and pull anything out, I just have 7 and 5. Those are both prime numbers. I don't have any groups of 2, so that's as far as I can go. All right, that one's messy. That one's got a lot of good stuff. Yeah, I like that one. All right, B here, let's take a look. Let's subtract 9. 1/4 x squared equals negative 9. All right, here's the trick. Dividing by 1/4 is the same thing as multiplying, right? So if we were dividing both sides by 1/4, that's kind of messy. Dividing by a fraction is the same thing as multiplying by the reciprocal. You might remember that. So instead of dividing by 1/4, I'm going to multiply both sides by 4/1. If I do that, 4/1 times 1/4 is just 1, so I'm left with x squared equals negative 36. Undo that square root, or I'm sorry, undo the square by taking the square root. I get x equals plus or minus, don't forget it, the square root of 36, square root of negative 36. Hey, negative, I'm going to have an I, yes you are, plus or minus. Square root of 36 is just 6, and that negative becomes my I. Good. All right, see here? Where'd it go? There it is. All right. Again, x squared and a constant. Let's add 12. X squared equals 12. You might see at this point that I don't have an imaginary solution on this problem, right? When I take the square root, I'm going to take the square root of a positive number. So I just get x equals plus or minus the square root of 12. Let's go ahead and break down that 12. What multiplies to 12? Well, 6 and 2. And then what multiplies to 6? 3 and 2. Here's my 2 2's. So one of them comes outside. And then I have a 3 that's left over. He doesn't have a buddy. He has to stay inside. There's my answer. Okay, no imaginary solutions on that one, you might notice. All right. So let's take a look at operations with imaginary numbers. All right, you might remember, because you have it written down, that I equals the square root of negative 1. Now, if we square that, if we square the square root of negative 1, you might remember that the square root and squared kind of undo each other. So therefore, we get I squared equals negative 1. Okay. If we square both sides, this undoes it. I squared equals negative 1. So this is important when we start to multiply imaginary numbers together. Memorize this. You see that it's in kind of a cloud. That means you're going to have dreams about this, so that you don't forget it on the quiz. Memorize. All right. So let's take a look. These examples here say square find the square of each imaginary number, okay? This just means square it multiplied by itself, all right? So 5i squared. Remember, squared just means multiplied by itself. I like to write out just multiplied by itself. It makes it a little easier for me. So 5i squared just really means 5i times 5i. All we're going to do here is multiply the numbers together. 5 times 5 is 25. I times I is I squared. And you might remember I squared equals -1. So really we have 25 times -1, which is just -25. All right, let's take a look at the next one here. All right, find the square. We're going to square this. And again, I always write this next to each other. So -I square root of 2 times -I root 2. And I'm just going to multiply each part together. So I have -I times -I. Remember, a negative times a negative is a positive. So I get positive I squared. And then I get square root of 2 times the square root of 2 is the square root of 2 squared. Remember, square root of 2 squared, though, those undo each other, so I'm just left with 2. So I get I squared times 2. Remember what I squared is, though, -1, right? So I get -1 times 2, which is -2. All right, one more here. We're going to square this guy. So I'm going to write it -√5 over 4i times -√5 over 4i. All right, the first thing you should notice for this, when we multiply two negatives together, right, we have a negative here and a negative here. These are going to become positive, okay? So I have positive. Now on top here, I have square root of 5 times square root of 5, which is just square root of 25. On the bottom, I have 4 times 4, which is just 16. And then I also have hidden in here I times I, which is I squared, right? At this point, I have the square root of 25 is 5, the square 16 on the bottom, and then this I squared, remember, is just -1. So I get -5 over 16. Okay. All right. This is kind of the exit ticket, so I'm just going to do one more here for you to see, and then you can come back to the Google Meet and start on the classwork/homework. All right, we've done a ton of these, but let's go through one more. Subtract 11 from both sides. So we get 4x squared equals -5. Divide by 4. X squared equals -5/4. At this point, start to recognize, hey, square root of a negative number, so this is going to be imaginary. All right, we get x equals plus or minus, don't forget that, the square root of -5 over 4. So a couple things here. I'm going to split up the top and the bottom, give them their own radical. So I get the square root of 5 on top, the square root of 4 on the bottom, and that negative becomes an I. Last thing here, square root of 4, we know that. That's an easy one. So luckily, I can just change that to 2. Okay, square root of 4 becomes 2. There's my answer. Nice and easy. Yeah, great job. Come back to the Google Meet and you can start on that homework.